Well, good morning, good students. This is Dr. Morgan over at Clovis East High School. We're going to look at lesson 3 in Unit 9 about box and whisker plots. We're going to look how to make the plots and how to interpret them. And that's going to involve finding another term called quartiles. Think quarters like in a football game. Instead of just dividing it in half like medians, we're going to divide it into fourths into quarters or quartiles. And then we'll discuss another concept that comes up at times called percentiles. So let's get started today. So let's start with a little problem just to give you a sample again of how we use data in real life. Suppose you're getting ready to move to a new area of town and you're looking for a warm climate. And it happens where you're working, you can choose between two towns, the town of Morel and the town of Glenville. And now we're looking at the average temperatures below and we're going to use them to decide which town we want to live in. So first of all, since we're looking for a warmer climate, how many months was the average monthly temperature greater in Morel than it was in Glenville? And you can see there were 4 times when Morel was higher. Let's see if I can spot them real quickly here. This was 1. This was 1. So during those 4 months of summer, that's when Morel was warmer than Glenville. The rest of the year, Glenville was warmer. Okay, so let's look at first what's the mean and the median temperature. Well, for Morel, the mean is, I add them all up, divide by 12, is about 69 degrees. That's the mean temperature. In Glenville, add them all up, it's about 72 degrees. So Glenville, the average temperature over the year is greater in Glenville by about 2 degrees. If I look at the median, put them all together, I can see the median there is about 69. So the median and the mean are about the same in Morel. And over here, the median is again, 71.5. So there really isn't much difference between the mean and the median. That means the data is spread pretty uniformly. So generally speaking now, if we're looking just at the average temperature, then Glenville is warmer. Although there's 4 months of the year when Morel is warmer during the summer there. What's the range? How much does it? In Morel, the temperature goes from 85 to 55. There's about a 30-degree change over the year. But in Glenville, it's 26. So typically speaking, you have to decide. Overall, Glenville is a warmer place to live, although during the summer, Morel gets a little hotter. And also Morel, the temperature changes more, gets a little colder and a little warmer. So you might, if you're just liking average temperature, warmer all year, on average, you'd probably go with Glenville. So let's look at a couple of vocabulary words we'll need for today. First, what's a box and a whisker plot? A box and whisker plot is a graph that summarizes the data along a number line. You see, here's a box and whisker plot here. And there's my number line right there. So I can see the parts of the box match up with parts on the numbers. Each whisker and each box represents a quartile, or 25% of the data. Okay. Now, the second word we're going to use at the end of our lesson is percentile. A percentile is the percentage of data values that are less than or equal to a given value. For example, in the class there were 25 tests. 15 of the tests had a score of 85 or less. That means 15 out of 25, 60% of them scored 85 or less. That's called being in the 60 percentile. We'll describe more of that as we go on. Separating data into subsets is a useful way to summarize and compare data. You may remember when we did frequency tables, we would divide the whole numbers into 4 or 5 different ranges of numbers, easier to describe. So similar kind of thing is going on here. Quartiles are values that divide a data set into 4 equal parts. The medium or the second quartile separates the data into the upper and lower halves. The first quartile is the median between the lower half of the data, and the third quartile is the median, the upper half. Think of it like a football game. There's 4 quarters, 4 equal sets of time. Each quarter has the same amount of time. Here we're taking the number of data and dividing it into how many 25% of the data is here, 25% of the data here, into 4 sections. Interquartile range then is the difference between the third and the first quartile. In this case up here, between this one and this one, you subtract that. That's your interquartile range. For a set of data that has an odd number of values, you do not include the median in either half when finding the first and third quartiles. And we'll explain that in a minute. In this data here, for example, I have a middle number. So when I go to take the middle of this, notice the middle, I don't include the median. But if that weren't there, you sometimes have data where there is no middle, and then your median is the average of those 2 numbers. And we'll give you an example of that as we go forward. So here's a graph that I showed you at the very beginning of our lesson, sort of showing you a box and a whisker and how it's all laid out. Again, notice we have a number line up at the top here. There's my number line, and there's my box and whisker lined up to it. Now notice in a box and whisker, your minimum and maximum point are the ends there. Your median, the middle point in the data, is the line in the middle of the box. And then the ends of the boxes are your quartiles, quartile 1 and quartile 3. Understand the median, the middle, is also could be called quartile 2. This is called the box, and these are called the whiskers. All right. Now, a key thing in terms of your data, 25% of your data is in each part. 25% data in each whisker, and the box has actually 50%, 25% on each side of the median. Okay. If each quartile has 1/4 of the data, how much data is in the interquartile range? Well, it's going to be between here and here, so it's going to be 50%. The range is the maximum minus the minimum. It's how far is it from here to here. And then, of course, the interquartile range is how far is it from here to here. So those are 2 different ranges we have. The regular range, the biggest data minus the smallest data. The interquartile range is that between the quartiles. So let's work an example. Construct a box and whisker plot to represent the following data. All right. First thing we have to do, as always, is to put it in numerical order. I've done that for you here. From 4 to 34. And so now we need to know a couple of things. First off, there's our minimum number, the smallest one. There's our maximum. Now the next thing we want to find is our median, our middle. So if we count over here, we discover there's 5 there and 5 there. Notice this time there is no middle number because it's an even number of data points, so there's 5 on each side. So what we have to do to find our median is we take the average of these 2 numbers here. Okay, so we're going to take the average of 14 and 15, and that's going to be 14.5. So our median is 14.5. Now when this occurs, and now I go to find my quartile, I want to find the middle of the numbers in each box. So in this case there's 5, so there is a middle. So my first quartile is 9, and my second quartile is 16. Okay. Now, by the way, notice if there were 6 on each side, I would end up doing like I did the median, where I would have 2 numbers, and I would take the average of those 2. So I'm going to take my dots now. Notice down here in the line, the minimum's at 4. My maximum up here is at 34. So that's going to be the ends of my whiskers. Then I have the number 9. 9 is my quartile 1. See, this is my minimum down here. This is my maximum. 9 is my quartile 1. And then what did I put on next? Next is 16. That's my quartile 3. And then the last thing I need to put here before I draw it is my median. Okay. Now I have the points, and I simply need to draw now. First, I'm going to draw my box. So my box goes between quartile 1 and quartile 3. And then the line down the middle is my median. And now we add our whiskers. And that gives me a visual picture of how the spread is. Now you got to remember, each section contains 25% of the data. So 50% of my data is sitting in between those in the box. And you can see the amount above the box is pretty spread out, but it's only 25% of the data is there. So let's try a second problem. Here, the data is already in numerical order, so we have the easy part done. So let's find the middle. There's my minimum. There's my maximum. Now to find the middle, this time notice I have 5 on one side, 5, and there is a middle number. So my median is actually the middle number, 23. Now we find the middle of the boxes. So the middle here is 17. There's a number in the middle, and there's a number 29. So first of all, our minimum number is 2. I'll put a dot there on 2. My maximum number is 31. Then here's 23. This is my median. "17" is quartile 1. And then over here is quartile 3. And now I can simply draw my box. There's my box between the quartiles. My median goes, the line in the box is the middle, the median, and then we add our whiskers, and we have it done. Unlike problem 1, notice most of my data is higher. The spread out data is really down below this number. Problem 3, we're going to use our understanding of quartiles and box and whisker plots to analyze data. So you see we have the data expressed for rainfall in Miami and New Orleans. So first question is, what are the IQRs? What's the interquartile range, and what do they tell you about the average monthly rainfall? Remember that an IQR is the difference between quartile 3 and quartile 1. In other words, how long is the box? So you notice for Miami, for example, from here to here, 7.25. From there to there, 7.25 minus 2.5. I see that my interquartile range is about 4.75. Okay. My interquartile range for New Orleans, however, is between here and here, and that's 6.1 minus 1. Now, if you think about that, what's that telling you? It's telling you that in New Orleans, 50% of the times it rains between 5 and 6 inches. Whereas 50% of the data in Miami is spread out between 2.5 inches and 7.25. There's just a greater spread on how much rain you get in any particular day. So the IQR for Miami is 4.75. The IQR for New Orleans is 1. This means that the middle 50% of Miami's rainfall varies more widely than New Orleans' rainfall. In other words, half the time in New Orleans, you're going to get 5 or 6 inches of rain a day. Whereas in Miami, half the time, you're getting half the time it's going to be raining, but it's going to be, one day it could be 2.5 inches, the other day it could be 7 inches. There's more variety. What do the medians tell you? Well, the medians, remember the median here you see is about 4.5. The median here is about 5 1/3 or so. So New Orleans has a higher median than Miami. This sort of tells you that the average, you get more average rainfall in New Orleans than you do Miami. Even though if you look at this, sometimes Miami, like take a look at here, sometimes Miami has those days like on a hurricane where it gets 8 and 9 inches, and you don't get that as often in New Orleans. But New Orleans on the average has more rain, more inches per rain when it rains than it does in Miami on the average. The box and whisker plot below represents the number of points that were scored each game by each person on a high school basketball team. According to the plot, what percent of the players scored between 4 and 10 points? Well, notice here, here's 4, and here's 10. In other words, How many of the players are in the box? Well, the quartiles and the median divide the data into 4 equal parts, which means each part is 25%. So how many parts is in the box? Well, the box represents 50%. So half of the players on the team score between 4 and 10 points per game. All right? Now we want to move into another category called percentiles. Percentiles take a little bit for you to grasp what they're after, but they are important because if you're ever applying to a college or you're taking state tests, they'll often not just tell you what you scored on the test, but they'll tell you your percentile, which is telling you how did you do to compare to other students. Now, percentiles, in essence, separate data into 100 equal parts. The percentile data of a rank of a data is the percentage of the data values that are less than or equal to that value. Percentiles are commonly used to report scores in tests like the SAT, the GRE, the LSAT. They rank a student's score in comparison, and that's the key here, in comparison to other students. It isn't what you got on the test, it's how well did you did compared to how other students do. For example, Marco scored an 87 on his last math test. That's pretty good. You know, that's a nice B. There were 40 students in his class, and 32 of them scored an 87 or less than Marco did. So as far as the class is going, he's got a B on the test. He did 80%. He got 87% of the test right. But in his class, it means that 32 students, and then so 32 out of 40 is 80. So in other words, 80% of the class either got the same score as Marco, 87 or less. 87 or less. So the percentile language says since 80% got the same number or less, we say that Marco is in the 80th percentile. Okay? So it's telling me how he ranks. He got an 87 on the test, but he's in the 80th percentile. So in other words, the test score, that's the percentage of points correct to the total points possible. Mario got 87 out of 100, 87%. But the percentile rank is how does his score compare to other students. And in this class, 80% of his class got the same grade as Marco or less. There were 20% of the class that just scored better than Marco. So because 80% scored 87 or less, he's in the 80th percentile. Again, your test score tells you how you did on the test. Your percentile rank tells you how you compare to other students. So let's take an example. 25 people take a test. 8 of them are less than or equal to 75. What's the percentile rank of a score of 75? Okay. So in other words, I want to find out how many students scored 75 or less and compare that to the total number of students. Well, the total number of students, 8 are less than 75, and there's 25 students. So 8 out of 25 is 0.32. That means that 32%, 32% of the class scored 75 or less. 30% class got a C or lower. That means that a test score of 75, if you scored a 75, you're in the 32nd percentile rank of 32. It means that almost a third of your class scored like you did or lower. 2/3 of your class scored better than you. So if a student scored 75 on this test, then they are in the 32nd percentile, which means that 32% of those who took the test scored the same as the student or lower, and 68% of the students scored higher. Again, your test score, 75%, that's how you did on the test. But how did you do compared to other students? You're down at 32%, 68% of your classmates scored better than you. All right, so let's try a second problem. This time we have 40 test scores, and 24 of them are less than or equal to 80. What's the percentage rank for a test score of 80? Well, the total number of students who scored 80 or below, that's 24, and the total number of students is 40. So 24 divided by 40 is 0.60 or 60%. That means if you scored an 80, you have a percentile rank of 60. Okay? You did 80% on the test, got 80% of the questions right, but in terms of your class, there's 40% of your class that scored better than you. 60% scored you or less, but 40% scored better. So if a student scored 80 on this test, then they are in the 60th percentile, which means that 60% of those who took the test scored the same as the student or lower, and 40% scored higher. Now, the last thing we want to look at in this class, in this lesson, is outliers. How do I find an outlier? We've talked about outliers before, but we've just sort of generally said an outlier is a number that's either much higher or much lower than the rest of data. Well, sometimes in math, we want to be a little more specific than that. Can you give me an example of what would be how would you measure that? One person would go, well, that's not as high, and the other person would say, oh yeah, that's really high. Is there a way? So I'm going to give you one way, one method, and there are several methods for determining an outlier. And that says if a number, a convenient definition of an outlier is a point which falls more than 1.5 times the interquartile range above the third quartile or below the third quartile. The interquartile range, remember, is this distance here. So in other words, what they're going to do is they're going to say, let's take, for example, let's take this range here, and then let's take it, and over here on this side, we're going to add it plus a half. So 1.5, and anything that's beyond this is an outlier. Likewise, we'll do on the other end. We'll take the length here, plus a half of it, mark here, and anything out here is an outlier. So if a number is more than 1.5 times this width on either side, then it's considered an outlier. We have seen that the presence of outliers affect the measures of central tendency, the median and dispersion range. As a result, statisticians often use the mean and the interquartile to measure central tendency when outliers are present. The above definition gives us a precise way to determine if the data point is an outlier or not. So let's take a look at how this works. All right, notice here's my box and whisker plot, and the red dots are different points. And we want to know if any of those points are actually outliers. So first of all, let's find out how long is our interquartile range. So the interquartile range you see is 28 minus 20, so it's going to be 8. Now remember, to find an outlier, it has to be not 8 more than the quartile, or 8 less. It has to be 8.5 of 8. So multiply IQR by 1.5. So 8 times that is 12. So what I'm going to do is I'm going to add 12 on to each quartile 3 and subtract 12 and quartile 1. And that's the acceptable range. Anything outside of that is considered an outlier. So if I subtract 12 from Q1, I get the number 8. In other words, you see from here, if I go back to 12, that's the range. So notice what point there is an outlier. You can see that A is an outlier because it's below 8. It's more than 1.5 the quartile that way. Now we do the same thing on the other end. We're going to add the 12, 1.5 the interquartile range, to 28, quartile 3, and that comes out to 40. And so you notice that comes out to here. And so at this time we have 2 points that are outside E and F. Okay? So the answer is, what are the outliers in this data? Points A, points E, and points F. So let's try this again with one more set of data. What are the outliers, possible outliers in this data? First of all, let's find the interquartile range. My median, if I drew my boxes, would be here. Notice that there are 5 data on that side, 5 on that way. So the median is between those two. The median is going to be, 16. But now my quartile range, my interquartile range, the Q 10 and over here 26. So my quartile range is 26 minus 10 or 16. So this would be, in other words, this is my box here. Now I want to figure out how far this way if I go 1.5 the quartile range. So 16 times 1.5 is 24. So in other words, if I start at Q1 and I subtract 24, 10, that's my Q1, minus the 1.5 the quartile range means minus 14. So that would be all the way over here to like minus 14 if this is on a number line. So notice on the left side, there are no outliers. All the data is within an acceptable range. When we go to the other side, now we're going to add it. So 26, this is my Q3. And now I'm going to add the 1.5 the quartile range is 50. So that's going to come out here to about 50. And now you notice, oh, there is one number bigger than 50. That's 60. So the number 60 would be considered an outlier in this problem. The outlier is 60. All right, that does it for today, guys. Do well on your homework. Keep well and keep safe. See you later.